Let's look at a practical application then, and then you can go off and actually start experimenting yourself with the system. So started off here with our now familiar ceiling circuit. So again, input 1 is our start button, input 2 is our stop button. In this instance I've used output 3, just because I'm using the other two for something else, as you'll see in a minute. And so output 3 is linked to its contact for output 3, which then locks the whole thing in place and allows it to run. We then scroll up. You can see that Q3 output connector is also connected to output 1. So that's actually going to get everything going, and that's actually our main motor start, which you'll see when we actually run through it. Scrolling up again, Q1, although it's starting the motor, it's also using another one of its contacts here, and it's feeding in to a timer. Now, timers we haven't looked at yet. Timers are massively useful, and there is, if you actually look in all of the instructions that you get that come with this package, there's loads of different timers, and one of the tasks that you need to do is actually set each one of the timers up with an input and an output, so you can actually see what it does. It's really important that you get an understanding of the flexibility that these timers have, because they can do so much. They're such a powerful element of PLC programming. So we can have a look at the parameters of this. We can see it's set for 5 seconds. If we right click on it and look at the block properties, it's an on delay. So all that means is that once the input becomes true, there will be a delay, in this case 5 seconds, before the output becomes true from the timer. So we can see T001 is controlled by Q1. Scroll up a little bit further. So there is the contact for T001, and that is controlling output 2. And then if we go up a little bit more, we can see input 3 is a really simple device which controls relay coil Q4. So it's not a massively complicated program. If we look at it as a function block, we can see again our familiar setup over here for our ceiling circuit, and then we can see the logic flowing off of Q1 going into the timer to control Q2, and then input 3 and Q4 is just a standalone down the bottom. Let's run a simulation on it. So here we have it. It's actually set up with momentary buttons for inputs 1 and 2, and then a flick switch for input 3, so we can turn it on. And as we can see, Q1 has become energized and Q3 has become energized, and then after 5 seconds you probably saw Q2 flicking on. I'm just going to run through that again so you can see that. If you watch here, you'll actually see the countdown timer clicking away until it gets to 5 seconds before this timer becomes true. So turn her on. 1 and 3 is on, and output 2 comes on now. So there we have it. All 3 are on. 2 of them are being used to actually control the external source, and another one is just an internal to actually allow Q3 is purely internal, and we could actually make that an entirely PLC born output, not actually a physical output at all, but I've kept it simple and made it one of my physical outputs. We've then finally got input 3, which we can flick, and that turns on Q4. Now that doesn't make an awful lot of sense until you see what it's running, so I'll set up with the actual device that I'm trying to operate, and then we can have a look and see how that works and see what the PLC is doing to make that effective. I've switched across to the network project view. I've got my diagram editor up. I had the previous program that we'd written just to turn our lights on already on there, so I highlighted and deleted it. I've cut and pasted the function block diagram that we used previously, that we had in the diagram mode, and I'm just going to right click and paste that in, and there we can see the whole thing. And actually for the first time you can see that loop that's coming up from Q3 and feeding back in to our OR gate that we've got here to enable the sealing circuit. So we're good to go. We're connected to the PLC, so I'm going to download it to the PLC to logo, click OK. It's in run mode. Yes, we want it to stop. It won't be able to change its programming if it's in run mode, so we need to tell it to stop. Data transfer is done, and then we're going to click yes, and now that program is stored in the PLC ready to go. By the way, this Q5 shouldn't even be there. Don't know where that came from, but we won't worry too much about it. Let's just delete it. That is our whole program in there. So let's now get the PLC running and connect it up to its output device. So it took a little bit of time trying to work out what I was going to use as my output device for this, and I saw this lurking around in the corner, something I did many years ago. It's a little plastic model of internal combustion engine. As it's a display piece, it's driven by an electric motor, so we can actually power it and see the pistons moving, etc, etc. Now remember I said about these relays and how we can trigger them. If we trigger this one, we can see rather noisily that the internal combustion engine is turning, and we can see from the fan that it's moving in a clockwise direction. So for this scenario, what I've decided is that this is a special engine, and this engine needs to spin for a full 5 seconds before we actually try and get it to run. So what we've done is we've separated the spinning of the engine from the ignition system. So the spinning of the engine, as we could see, was powered by this first coil here. The second coil here, and it'll be lucky if we can get a light on, depends on it's not quite in the right position. The second coil turns on the ignition system, and because within the PLC we have a 5-second timer, that means that the engine can get up to speed, if you like, before we introduce the ignition and get the engine to run. The third output that we had, which was connected to Q4, is a very simple DC polarity reversal switch. Now that's something that you can look up online. You can find out how to do very easily. Apply a little bit of thought to it and you can easily work out how to facilitate that, providing you use a double pole, double throw switch. So that's a little bit of homework that you can do to work that one out. But if we now run through the whole procedure, we can actually see how the PLC can control this little engine unit and give us not only the startup procedure that we like, introduce the ignition at the point that we need it to, and even when perhaps I'm too lazy to change gear to park, I can actually run the engine backwards so that I can get into that difficult parking spot. So although I don't have momentary switches, what you'll see is I can flick the switch down and then pull it back up and the engine will run because of the sealing circuit. So we're running, the countdown is counting to 5 seconds, at which point we saw the light come on here, and if you look at the engine you can see the little red lights of the ignition coils firing for each of the strokes within the engine. This will now run continuously until somebody comes in and flicks the second switch, which is our stop switch, and we'll turn the whole system off. But if I wish to reverse the flow of the engine, by flicking switch 3, you can now see the ignition is still running, the motor is still running, but because of our changeover relay which has been energized, the engine is now running backwards. And I can flick that back up again, and we see we get back to the standard clockwise motion. Turn off, and the engine stops instantly. Now, okay, it's not a particularly realistic scenario. We would never control an internal combustion engine like that. But as an example of something that we need to start something and then introduce another element, we can see the timer at work. We can see the ability to reverse the flow by using the changeover switch to get the whole system to run backwards. You can imagine that being a very effective method for running, for example, a conveyor belt. So the conveyor belt starts moving, then after 5 seconds the other processes start to get into operation once the conveyor belt has perhaps reached the correct speed. We might also want to be able to reverse the conveyor belt if it misses the station that it needs to be at. So having the ability to remotely reverse it is very, very useful. Now this is just really scratching the surface of what we can do with PLC. There's lots of other exercises that you can go through, but the most important thing is to start practicing, to start experimenting, to start putting timers in, to start putting counters in. Literally go through all the facilities that you have in the function block diagram programming mode, put them into a simulation, see how they run. Once you've got an understanding, you can start to build your own circuits that allow you to control multiple machines.